We're talking about sine, cosine, and tangent. So what I want to do is start, so this is not on the graphic organizer, but I want to remind us about similar triangles. So I'm going to draw two right triangles, and I'm going to say that both of these triangles have a 53-degree angle, for example. Well, we know from what we talked about last chapter that these two angles are similar by angle. They have two congruent angles. And that would be true for any particular angle that this, if we had a 90-degree angle and any other angle, where both were 65-degree angles, 72-degree angles, whatever, those triangles would be similar. So we know the sides are proportional. So what we do with trigonometry is, because these sides are proportional, some of the ratios, proportional means same ratio, some of the ratios we give special names. Because if we have a triangle, two triangles with a 53-degree angle, two right triangles with a 53-degree angle, the ratios are going to be the same for both those triangles, no matter how big, no matter how small. So we give them special names because things with right triangles come up often in math. So the sine, cosine, and tangent are just some of the special names that we give those ratios. So trigonometry, sine, cosine, and tangent, is about similar triangles, and sine, cosine, and tangent are just names that we give to particular ratios. So that's our background for this. So on to the graphic organizer. So here's our big triangle. So the capital letters A, B, and C are angles. And the small letters A, B, and C are side lengths. So our first special ratio, the sine of angle A is, we give that ratio a special, we name a ratio the sine of the angle. It's the opposite over the hypotenuse. And on your graphic organizer it says the opposite leg. So on this triangle, our abbreviation for sine is SIN. We pronounce it sine. Sine of A is the side that's opposite angle A, side A, over the hypotenuse, C. So that ratio, opposite over hypotenuse, for that angle, we call the sine of the angle. And so sine of B would be the side that's opposite angle B. Opposite is all the way across the triangle. That side is B, divided by the hypotenuse. So the sine is just a name that we give to that particular ratio, opposite over hypotenuse. The cosine of angle A. That's the name that we give the ratio adjacent side over the hypotenuse. Adjacent means next to. Our abbreviation for cosine is COS. We pronounce it cosine. Cosine of A, the adjacent side, is B over the hypotenuse. The hypotenuse is always the hypotenuse. The hypotenuse is never the opposite side or the adjacent side. Always the hypotenuse. So the cosine of B is the side that's adjacent to side B, next to side B, A, divided by the hypotenuse. So cosine is just the name that we give to that ratio, adjacent side over the hypotenuse. Yeah.
So for the sine ones, why is A opposite?
This is angle A.
Yeah.
So the side that's opposite angle A all the way across is side A.
Okay, so what would be opposite A?
Opposite of C would be side C.
And B would
B.
be.
Opposite means all the way across the triangle. Okay? Tangent of angle A is the opposite over the adjacent. So for this particular triangle, our abbreviation is TAN. We pronounce it tangent. Tangent A, opposite side is A, the adjacent side is B. And the tangent of B is the opposite side of B, B, over the adjacent side, A. So the tangent is just the special name that we give the ratio, opposite side over adjacent side. And if we know one of the angles in the right triangle, those ratios are going to be the same for any triangle that has that, any right triangle that has that particular angle in it. All right, so we have an acronym to help us remember how these ratios work out. It's written down at the bottom of your graphic organizer. That's, we pronounce it Sohcahtoa. And Sohcahtoa means that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So Sohcahtoa is just an acronym to help us remember how those ratios work out. So what I usually do for the quiz and the test is I just write this Sohcahtoa up on the board to help us remember how the ratios work out. So what I want to do is go through some examples of how we're going to use sine, cosine, and tangent to solve various kinds of problems. So the first example, if we want to write the sine, cosine, and tangent ratios, and I'm going to draw a triangle here, and this is going to be a nice triangle with Pythagorean triple for sides. And I'm going to call this angle, in trigonometry a lot of times, often, usually, we use the symbol for angles called theta. It's a Greek letter, just like an O with a line through it, just another letter. So we want the sine, the cosine, and tangent ratios for angle theta. So what we're going to do for any problem that involves sines, cosines, and tangents, just like we did for Pythagorean theorem, just like we did for special right triangles, is we're going to label our triangle. Well, we're going to label it opposite, adjacent, and hypotenuse. So this is our angle. Which side is the hypotenuse here? 5 is the hypotenuse. So I'm going to label that HYP. 3, is that opposite or adjacent? Opposite means across, adjacent means next to. That's going to be opposite. So this means that's the adjacent side. So what this problem is asking us to do is say that the sine of our angle, sine theta, is opposite over hypotenuse. 3 over 5. Cosine theta, adjacent over hypotenuse, 4 over 5. And tangent theta is opposite over adjacent, 3 over 4. And that's all that problem's asking us to do. It's just asking us to write those ratios. Hmm? Yes, we'll talk about that in just a bit. So if it just asks you to write the ratios, it's just saying use the sides of the triangles and write those ratios. All right. If we know an angle, the calculator will tell us the ratio. So, for example, if we wanted to find the cosine of 38 degrees, our calculator will tell us what that ratio is. We know the particular angle. That quantity is important enough that our calculators, scientific calculators, do this calculation for us. So what I'm going to do is go to my calculator, clear that out. The first thing that most of your calculators are going to look something like this. First thing we need to do is make sure our calculator is in the right mode. So I hit the mode button, and here it says DEG. That tells us we're in degree mode. That's where we want to be. So that's okay. Quit out of there. So we want to do the cosine. Well, there's my cosine button of 38. Just put it in the calculator just like we wrote it. I'm going to do this. I'm going to do that. Close my parentheses, hit enter, and that tells me the cosine of 38 degrees is about 0.79. So the ratio, adjacent over hypotenuse, for a triangle, right triangle, with a 38-degree angle, is 0.79. All right, questions there? If we know the ratio, the calculator will tell us the angle. To find an angle, we use the buttons that look like this. Sine minus 1, cosine minus 1, and tangent minus 1. And we call these the inverse sine, cosine, and tangent. The cosine of an angle is a ratio. The inverse cosine of a ratio is an angle. So from this problem that we did before, we knew that the sine of our angle was 3/5. So our angle, theta, is the inverse sine of 3/5. And I'm going to plug it into my calculator exactly like this. So I'm going to go to my calculator. I'm going to do the inverse sine, so that's the shifted one here above the sine. Inverse sine of 3 divided by 5. Close my parentheses. And that tells me that angle is 36.9 degrees. And I can do that for any of those ratios. We said before that the cosine of theta was 4 over 5. Well, if we wanted to find the angle from that ratio, our angle would be the inverse cosine of 4 over 5. And I go to my calculator. Inverse cosine right here above the cosine. 4 divided by 5. And I need to make sure I close my parentheses. Otherwise the calculator will do something else. It'll do the inverse cosine of 4 and then try to divide that by 5, which is not the same thing. Hit enter, and it should get the same angle because we used that angle for the ratio. So that gives me my 36.9 degrees again. And I could do the same thing for tangent. We knew from that triangle a tangent of my angle was 3/4. So the angle is the inverse tangent of 3/4. And I better get the same answer there. It's the same angle. So I'm going to do inverse tangent. 3 divided by 4. Close my parentheses. Enter, and I get 36.9. And if I knew any other ratio, I could find the inverse sine, the inverse cosine, or inverse tangent to figure out the angle. So our calculator will tell us the ratio. We find the sine, cosine, or tangent of our angle, or it will tell us the angle. We do the inverse sine, cosine, or tangent of the ratio. All right, questions there? Okay. Let's talk about how we're going to use sines, cosines, and tangents to actually solve problems. Not just calculate them, but we want to solve problems with them. All right, so I'm going to make a list of steps. When we're using sines, cosines, and tangents, we're going to follow these steps. And the steps for these kinds of problems are always the same. First, label the triangle. When we're using sines, cosines, and tangents, we want to label opposite, adjacent, and hypotenuse. Our second step, we want to use Sohcahtoa to decide which ratio to use. So it depends on which sides of the triangle that we're given, which ratio we're going to use. 3, we're going to write an equation. So our equations are going to be, we have 3 different equations that we could have. We're going to write the sine of whatever angle we're given, whatever angle we're interested in, and that equals the opposite over the hypotenuse. So if our problem has an angle, an opposite, and a hypotenuse in it, we use sine. We could possibly write the cosine of the angle is the adjacent over the hypotenuse. So if we label our triangle and we see, oh, we have an angle, we have an adjacent side, and we have a hypotenuse involved in the problem, we would use cosine. Or we would use tangent of the angle equals the opposite over the adjacent. So if we set up our problem, we label our sides, we say, oh, we have an angle, an opposite, and an adjacent side that's involved, we use tangent. After we write our equation, we're going to solve for what we need. And the last step is then, after we do everything, plug into the calculator. So I just want to go through a few examples of setting up and calculating problems that involve sines, cosines, and tangents. All right, questions so far? All right, first one. Here's my triangle. I'm going to say this is a 90-degree angle, 34 degrees, x, and 9. And we want to find x. All right, so let's label this. Is 9 the opposite, the adjacent, or the hypotenuse? 9 is the hypotenuse. And the angle that we're interested in is this 34-degree angle. So is x the opposite or the adjacent side? It's the adjacent. It's next to. The hypotenuse is always the hypotenuse. It's never the opposite or adjacent side. So then we say from Sohcahtoa, which ratio tells us about the adjacent and the hypotenuse? Cosine. So we're going to use cosine. So we're going to write the cosine of our angle is the adjacent over the hypotenuse. Now I want to solve for x. So how do I get rid of that 9? Multiply everything by 9. On this side, the 9's cancel. 9 divided by 9 is just 1. And I get x equals 9 times the cosine of 34 degrees. And I'm going to go to my calculator and calculate it exactly like that. Clear that. 9 cosine 34. Close my parentheses. And I get 7.5. Rounded to the 10. All right, questions? Okay, let's look at another one. There's my triangle. All of our problems that have to do with Sohcahtoa are going to be more or less like these problems. And we want to find x. So let's label our triangle. Is x the opposite, the adjacent, or the hypotenuse for the 49-degree angle? Let's see adjacent side. Next to. 7, opposite. So then we go to Sohcahtoa. We say which ratio tells us about the opposite and the adjacent? Tangent. We're going to use tangent. So we'll write our equation. Tangent of 49 degrees equals the opposite, 7, over the adjacent, x. So when we have the x in the denominator, we have a little bit more work to do. So what do I do to get that x out of the denominator? Multiply both sides by x. So I'm going to multiply by x, those cancel. And I get x tangent 49 equals 7. Well, I want to get x by itself. Tangent 49 is just a number. What is it doing to the x? Adding, subtracting, multiplying, or dividing? Multiply. How do we undo multiplication? Divide. So we're going to divide both sides by tangent 49. Tangent 49 divided by tangent 49, those go away. And I get x equals 7 divided by tangent 49. And I'm going to calculate, plug that in my calculator, just like that. Go to my calculator, clear that. 7 divided by tangent 49. Close my parentheses. And I get about 6.1 rounded to the 10. All right, questions there? So all of our sine, cosine, tangent problems are going to look somewhat like this. So let's look at another one. Here's my triangle for this one. $25 degrees, 65 degrees, call that x, and that 15. Well, I have two angles here. How do I know which one to use? Can we just pick one? Yeah, can we just pick one? If we have all the angles, just pick one. You can use whichever one you want. And then you just use the ratio that fits with the angle that you chose. So which one do we want to use? Let's use 65. That's fine. We could do it either way. The problem will work either way. So I'm going to say choose an angle. Doesn't matter which one we choose. But we don't want to choose 90 degrees. We don't do sine, cosine, and tangent with 90 degrees. We always do it with one of the other angles. All right, so now we're going to label our triangle based on this. Is x opposite, adjacent, or hypotenuse? That's the adjacent side. Right next to it. 15? Hypotenuse. Hypotenuse is always the hypotenuse. And then we say cosine, because it's the adjacent and hypotenuse. So we'll write our equation. Use cosine. If we chose 25, what would be different? What would this side be? Opposite. So we'd use sine. And that's how the problem would come out correctly. So we're going to use cosine for 65. So the cosine of 65 degrees equals the adjacent over hypotenuse, x over 15. We want to get that 15 out of the denominator. So we multiply. Those go away. And I get x equals 15 cosine 65 degrees, calculated exactly like that. 15 cosine 65. Enter, and we get 6.3. If I did 15 sine, if I had chosen 25, I get the exact same answer. So it doesn't matter which one you choose. As long as you set up your ratio right, you're going to be fine. So x is going to be 6.3. Yeah. When he comes back. All right, last example. Just want to look at one more. Here's our triangle for this one. And I'm going to call this x. There's my 90-degree angle, 23, and 3. And we want to find x. All right, so this is my angle. Let's label our triangle. Opposite, adjacent, or hypotenuse? 23 is the hypotenuse. 3 for angle x. Opposite. So which ratio is opposite and hypotenuse? Sine. We're going to use sine. So I'm going to write the sine of my angle is opposite over hypotenuse. Well, now I have the ratio, and I want to find the angle. What do I have to use? We want the angle x. What's that? No, so we said right after we talked about sines, cosines, and tangents, when we want to find an angle from a ratio, we use the inverse. To find the angle, we need to use the inverse sign. So x is going to be the inverse sine of 3 over 23. So when we find an angle, we need to use the inverse. So I'm going to put in my calculator just like this. Clear this away. We're going to do the inverse sine of 3 divided by 23. And that tells me that angle is about 7.5 degrees. So when you find an angle, you have to use the inverse. All right, questions? So all these problems, you set them up exactly the same way. Label your triangle, pick your ratio, write your equation, solve for the part you need.